Okay, this problem says find the center of mass of a thin wire of mass m and length L bent in a semicircular shape. Let the origin be at the center of the semicircle and have the wire arc from the positive x-axis across the y-axis and terminate at the minus y-axis. Okay, so the mass of the wire is m and the length is L. Okay, and so find the center of mass of the thin wire. Okay, so we want to find the center of mass of this semicircular wire. Okay, now if you had this full circle, that would have been easy. The center of mass would have been at the center. Okay, so from the symmetry of the problem, the center of mass of this object is somewhere there. Okay, the center of mass is somewhere there. And of course, the x-coordinate of the center of mass is 0, so y center of mass is what we are trying to find. Okay. All right. Let me. So here's your x-axis, here's your y-axis. You guys understanding it so far? All right. So now we'll do integrals. So you guys can check this out. Y center of mass is y dm divided by dm. That's the integral. What this integral is saying is, so let me write down the other expression. Y center of mass is mi yi sum over mi. Okay, so this formula says the y coordinate of this piece, you add up all of that and divide it by the total mass. So for a continuous mass, what we'll do is we'll divide it into little pieces. This will be dm. There's the y coordinate of that piece. And the y coordinate of that piece is theta sine theta r sine theta. Okay. dm and sum over all dm. Okay. Yep.
dm referring to
The piece, the mass of this little piece.
the mass. Okay.
This little piece. Everybody understand? Okay, so again, this is the y. So we are looking at this piece. The y coordinate of that piece is that. The y coordinate is just r. There's the angle, theta. R sine theta. R is the radius of the semicircle. R sine theta is this y. dm is the mass of this little piece. Okay, the mass of the whole piece is m. So now let me write what dm is. So let's make sure. Okay, I need this space, so I'm going to erase this. dm is the mass of this little piece. This piece, let's say, there's the angle theta, d theta. All right. So, hey guys, Mina, you need to be paying attention, my friend. All right. That guy is a lost case. I won't even worry about him. Uh-huh. All right. See, I only yell at you because I love you, man. What's that? I'm sorry? I still don't hear you. I'm tired today. Yeah, let's move on. Okay, so this is the mass of this little piece. Okay, d theta is the angular dimension of that piece. D theta is the angular dimension of that piece. What is the whole angle? Pi radians. Okay, now we'll have to do this in radians. Okay, so, oops, d theta by pi times m. Okay. All right, so that's dm. Okay, now we are all set. Okay, but before the sum of all those little pieces is capital M, so I'm going to write that down, sine theta dm, and that's capital M. Okay, so now r is common, sine theta, r is constant, dm is d theta m by pi d theta divided by m. Okay, and now what is the integral over? What is the theta changing from? What to what? From 0 to pi radians. Okay, so the integral goes from 0 to pi. All right, so now r by pi, the m cancels, 0 to pi sine theta d theta, and that's the center of mass. Okay, so what this problem is showing you is how to set up integrals. Okay, what you're using, well, let me finish this and then I'll review the problem again. Okay, r by pi, the integral of sine theta is minus cosine theta, 0. Minus cosine pi is, pulled out the minus sign, is minus 1, minus cosine 0 is 1. Okay, so there's the center of mass. And so 2 pi is a number less than 1, pi is roughly 3, 2 pi is 2/3 roughly, r, and that's a good thing because that means y is within this thing. All right, so that's 2/3 r roughly. That's what we're saying. Okay. All right, again, what did we find? We found the center of mass of this semicircle. Okay, and that is 2/3, roughly 2 by pi. It's 2 by pi r. Okay, what we did was we set up this integral for a continuous mass distribution to find any coordinate, x, y, z coordinate of the center of mass of that object. It is, you break up that object into little pieces, the y coordinate of that little piece divided by the total mass. Okay? That's the formula. So we took this mass distribution, we broke it up into little pieces like that. We got an expression for the mass of that little piece. We found out the y coordinate of that little piece. Y coordinate was r sine theta, and did that integral. Okay? All right.
underserved mass given the density.
Yeah, then you would just express the mass.